Hello everyone, I'm Blessing Adesiji, a developer advocate here at Circle. Let's talk about generating and encrypting entity secret. In this section, we're going to review generating the entity secret and encrypting it as part of the basics for building with a developer-controlled wallet. If you are interested in building a user-controlled wallet, we have a different video for that, and I have a link in the description below for you to check out if you're interested in the user-controlled wallet. I'm sure the first question on your mind is, what is an entity secret? Well, an entity secret is a confidential password required to seamlessly access the features of a developer-controlled wallet. The entity secret is a 32-byte private key designed to secure your programmable wallet. It acts as your secret password, your personalized cryptographic stamp known only to you. It is important that you know that we do not store this secret. The responsibility for its management, encryption, and secure storage entirely rests with you, the developer. Let me show you how to generate your entity secret by sharing my screen, and then you work with our sample codes that we have for multiple programming languages. So you can see right on my screen the sample code for generating the entity secret. So you can access this repository by visiting this link as shown. We have a couple of sample codes for multiple programming languages, so you pick the one that you are most comfortable with. We have for Golang, Node.js, and Python. All you need to do is clone this repository and work with it in your local development environment. I've cloned this repository and my programming language of choice is Python. You can see right here is Python, right? So I'm going to work with the Python code to show example of how to generate your entity secret. You can see on the screen that I have this small sample code in the generate X encoded entity secret file. What I will do is I'll run this sample code in my local environment, and that will generate an entity secret that will work with, and then we'll show you how to encrypt that. So I'll right click on that and then I'll run Python file in terminal. You can see right here that we have this X encoded entity secret. So that's the first step. After generating this X encoded entity secret, the next thing that you need to do is to fetch your entity's public address, and I'll show you how to do that. To generate the public key for your entity, what you need to do is you navigate to the developer API reference in our developer documentation, and you can use this URL as shown to access that. And we're going to work with the public key, the entity public key endpoint. We're going to put in the API key, and then we're going to send the API request, and then we'll get the result back with our public key. I'll grab my API key, replace it in this field as shown, and then I'll click on this try it button. I replaced my API key already to the recent one I'm working with, and then click the try it button and notice the response that we got here. We got a successful response, a 200 response. So all I need to do is copy this and then store it somewhere where I can access the public key. After getting the public key for the entity, what I'll do is I'll navigate back to the code. The next step is to generate the entity secret ciphertext. What is an entity secret ciphertext, you might ask? The entity secret ciphertext is a RSA encryption token generated from your entity secret and Circle's public key. Remember the entity secret we generated in the first step, and then the public key that we generated now, we're going to use that to generate the entity secret ciphertext. So the entity secret ciphertext is really important in API requests that are critical. For example, wallet creation or transaction initiation. You want to ensure that those API requests or those actions are very well secured. So you use your entity secret ciphertext to make sure that those API requests are very secure. Let's walk through the code. This code uses the RSA and the RSA optimal asymmetric encryption padding to encrypt the entity secret and then encode the entity data in base64 format. Like I said, all I need to do is I'll replace the public key string right here, and then I'll also replace the X encoded secret right here to make sure it's the current one that we've just generated. I've copied my public key, and then I'll paste it right here. That's done. Then the next step is to replace this X encoded entity secret. So I'm just going to copy this that we have in the terminal, and then I'll replace the old one as shown, and then we have the X encoded entity secret. So all I need to do is just run this file. If you're interested, you can take a look at how the code works and understand that. But for the purpose of this tutorial, I'm just going to run this Python file in the terminal. So after running the Python file in the terminal, this is our Entity Secret Ciphertext. And we got that by using the entity secret we generated in the first step, and then the public key that we just fetched, and we use that to generate the ciphertext. That brings us to the last step of this section, which is registering this ciphertext on the developer dashboard. So all I need to do is copy this ciphertext and then navigate back to the developer dashboard. So you can see right here, all I need to do is scroll down to dev control because we're working with developer controlled wallet, and then I'll navigate to configurator. In this section, basically what this section is doing is you are registering this configurator. That's like the first step before you start making API requests. It is really important to do this step because you want to make sure that critical API requests like wallet generation, transaction initiation are very secure, and this is how you do that. Feel free to read the information we have right here, but all I will do right here is paste this and then I'll register it. So after registering, we got like a modal that quickly went because I clicked on download and I downloaded that. So this is the recovery file. And with this recovery file, you can use this recovery file to reset the entity secret ciphertext in case you need to do that. So once you click on this, you drag and drop the file we just downloaded right here, and then you paste in the new entity secret ciphertext. Before we end this section, note that the entity secret never changes, but the ciphertext must change often, and that changes every time you need to do a new transaction. All you need to do is rerun this code that we have right here, and then you generate a valid entity secret ciphertext for your transaction. We are working on the server-side SDK to make all this complexity really easy for you to work with, and that server-side SDK might be available as at the time of you watching this video. That's it for this video. In this video, we talked about generating entity secret. We showed you how to fetch your entity's public key, and you use that to generate your entity secret ciphertext, and then you register the entity secret ciphertext in the developer console. Now you are ready to start building with developer-controlled programmable wallets. Thank you for watching. My name is Blessing. See you in the next video.